It's been a long time since I've done a presentation. Thanks everybody for coming. Yeah, so I missed your introduction, I guess. All this
MMaC, yeah.
Basically, what Marauders as code is I use LLMs, of course. Everything here I think is AI in some way or another, right? But I actually don't rely on it as the core of the tool. So it was generated using AI, and then the code that is generated is actually profiles. So we'll get into that. But basically, premise is that your GitOps practices and your repositories are all that you need to develop both attack and defensive capabilities against an application or I started looking at this when I was a few years ago, I guess, before LLMs and AI kind of really took off. And basically everything that I was dealing with insider threat and some other things. And so I was trying to figure out how to determine where these individuals were going to take action next. And so I started doing the ego profiles on teams and stuff like that. So insider threat kind of sucks to do. I don't know if anybody here done insider threat stuff? Yeah. Fun
stuff. Especially if they got privileges. Yeah.
So I watched him basically systematically disable logging and elevate privileges and then change policies and kind of take over the environment. And what really kind of stunned about that was that insider threat is one of those unbelievable for most people attacks that's going to happen. Like they don't want to believe that insiders that they've let them into their companies or organizations or that they're continuing to do damage. Right. So I didn't have a lot to go on. Obviously, in those kinds of situations, you can't just be like, "Hey, who's the insider threat today?" Right. So that's kind of where Marauders started. And when LLMs took off, I was looking through research papers and stumbled across some theory of mind stuff. So I will. There's a citation in here for modeling other people's minds as code, which is a paper on ArcSID. So I started looking at that and thinking, wow, if that works, that's going to be really kind of interesting, right? So that the premise of that paper is that you can take all the behaviors or all the actions of an individual and cut out all the stuff that you would consider kind of standardized behavior. Meaning things like, if you're standing in a crosswalk, the light turns green, right? The crosswalk indicator turns a step into the crosswalk. You can kind of assume that their next steps are going to be to cross the street, right? So in terms of modeling behavior, you can cut all of that out. And it leaves you with a unique set of behaviors that are differentiators in terms of how people behave in relation to the systems or the processes that they're going to. So, and basically for GitOps, it turns out the whole process is explicit, right? It's intentionally developed in order to define, deterministic infrastructure processes that are going to deploy that and the actual individuals that are going to do those actions. So that's kind of what Marauder is. It's always been there. It's just that we didn't necessarily have a lot of the tools necessary to evaluate those things. Yes, before I continue, I'm Benjamin, datapleX. I've been doing security stuff for like 30 years and I like to mess around. And I come at it from an attack mindset first. And then once I kind of understand the attack path, it lets me build defenses against those things. So the cool thing about Marauders map is it is both attack and defense capable. I'd like to throw a shout out to the Anthem. Jesus Rude and Marauders. Also, Andy at Halo Auto. Just on group here in San Antonio. BSides, and thank you for the volunteers and the organizers. So what are we doing in the next 40 minutes or so? We're going to start looking at the GitOps, its behavioral, can't see that, archives, right? and then profile the contributors. This step, it's going to have it's probably where the most time in terms of actual conversation should happen, right? Is this ethical to the profiling people? And there was an earlier talk about governance around AI and making connections of data that weren't previously possible with public data. And I do think that's been of a concern, right? Nobody that set out to do GitOps 5 years ago or so expected there to be a technology that could correlate their actions across time to potential attack vectors. Right? And it's the same thing as code reviews. Nobody really wants to say like, oh, the thing crashed because Tim didn't really review the code very well and that's kind of exactly what we're going to look at. So in order to kind of match those against some vulnerability IDs, I have anything better. LLMs put things in places. So there you go. Yeah. Each one of those, there's 12 of them that I profile here that are based on just Git, the repository, only requiring a read token to pull commit history, basically, and attribute history. It gets really dangerous, actually, when you start combining those into escalation paths, into persistence, things that, would have. We'll look at some of the cases with like XZ and SolarWinds in terms of how that might have been detected and prevented. Both of those actually ended up with dormant accounts that became active long after they were not used, but had retained their privileges. And then they were able to, the attackers were able to leverage that trust into execution. Next, we got kind of lucky. Finally, go look at the kind of demos on this and then the defender side of it. So, Marauders map is originally like a Harry Potter thing. Probably went too hard into that, but it is what it is. But it is very much a similar thing, right? In that series, the map was basically, you could say, I solemnly swear I look so good, and show you all the paths in the castle and the individuals that were in there as well. So this is doing the same thing with GitOps repositories, and I do it across GitHub and GitLab separately. So, any questions so far? Cool. So GitOps is actually meant to capture the behavior of code and the processes that deploy code, right? Up to this point, that's been really fantastic in terms of reliability, the speed at which we can deploy things, right? The consistency and the number of people that are participating in that. And now we're actually, like most other things with AI and LLMs in place, because they're so good at pattern matching. It's not necessarily that it's, this is reliant on that technology, but I was able to use that pattern matching to generate enough code that it covers a significant amount of use cases very quickly. And I tend to not, want to rely on LLMs. So I have it generate, executable artifacts that I can verify out of band and that I can use offline and things like that. It does have LLM integration layer if you want to pass it in, so it can do more behavioral analytics on certain, characteristics that may not be standard, I guess. But yeah, go to the commits, pull requests, CI/CD runs if we can get access to, commission this, all of which are accessible on GitHub and GitLab both just with a read token. You can sign in with your own account and the repo is public. You can get all of this. It's private and you're added as a contributor. You get access to all of this. And so the other part of this that's kind of devious is that you're not going to see that traffic that's going through there holding that repo, right? Typically, you're looking for things like writes or workflow commits and things like that. And this really issue where it kind of shines in terms of an attack behavior is it's going to model that repository and discover things like when do they do releases? Are they on a 2-week sprint? Where's every 2 sprints they do a release? Do we have juniors and seniors mixed on a team, right? Do we have juniors that are overloaded? Happen to commit code that often fails and requires a rebuild? Are we targeting infrastructure that is prone to failure? If y'all ever tried to deploy a Kubernetes cluster, just straight up from, FIFO Kalbai. So it started to pick up on this pattern as in it can do things like, next Friday, you should, hit Tim at 5:20 with an email from a senior engineer relating to the infrastructure that's likely to be deployed. That infrastructure is very likely to fail its deployment. And now we have an out-of-band process that's likely going to result in a force purge, right? It's going to bypass branch protections and we have an entryway, regardless of whether or not the infrastructure and the state of that infrastructure is actual bolt or not, right? So it's targeting the contributors and the processes that they interact with. Rote is so this is a play on the words because the actual original paper uses rote as repeatable operation, something simple. I can look it up there with the if y'all are really interested. And I'll have a link to the paper. But in terms of what we're doing, I'm gonna read basically full commit history, PR events, workflow routes of React. GitLab by default turns that off, I think. Now they did not previously, so all the repositories will have that enabled by default. And if we can get to is we'll pull issues from the repository as well, which provides a lot of that context metadata that's real helpful in establishing like what methodology they use and what their timelines are. We're going to observe this. So yeah, I've been running this now for probably several months, I guess, and I have a sample of about 50 repositories that I ran. I did try and analyze some of it. So there are, identified adheres, attacks. So please don't do that ethically. And then translation is basically taking the profile that it generates for each contributor and running that across a matrix. So it's going to call them MIME types, right? So that'd be like contributor, maintainer, owner, release manager, CI/CD system. So I also treat systems as minds. And my definition of mind is anything that can make a decision that influences the real world, that uses information that you don't have full access to make that decision. Right. In that case, CI/CD systems are going to be minds. Your ticketing system would be a mind, right? And by broadening, I guess, that definition of a contributor, we get to look at all the interactions between both humans and non-human systems. And finally, we basically use those and score them against indicators of either activity that's present or conditions that would be conducive to, exploitation or vulnerability being present. I have 12 that I put the presentation here, and I will. I'm going to release probably the free tools that I made for this, but the rest of this is going to come online. This is unsafe for AI later as a service, so it pulls in a lot more integrations and does a lot more about implementing. Let's see if I forget that BBI. Pretty much everything you need to know about that project, right? I don't have to have access to your Terraform state or your ARM, state, your Azure or what environment, AWS environments. As long as I can see that your workflow has something like a Terraform reply or an Azure deploy, right, and that it has run recently, I can fairly, confidently assume that whatever the definitions of that infrastructure are in that repository is likely what's actually in the environment. And so I don't have to actually even go target that stuff. I can build that attack surface now outside of that with only the access to that repository. So that keeps the noise really low, unfortunately, for the defenders. And it also means that those attacks are going to be very targeted and very likely successful, right? Because they can target the operating system, the network, everything that's built up on that stack. You can have form body blocks. You get permission escalations, membership changes, branch protection edits. That was really nasty. If you see branch protection edits, you should probably just, deaden that account immediately, unless that's a pre-approved process. It's going to happen. And this is the other thing that I found kind of LMs to be good at. Although, yeah, I was able to take this out of this process pretty much entirely. But behavioral baselines, we had UBA, user behavioral analytics before, and a lot of that was kind of static plugin based code. So they would do extensions. But I mean, you think about your 5-day work week and your 2-day weekend. And I know that a lot of the UBA systems struggle to say like, well, what do you do on Monday morning when you've had 2 days off of no activity and all of a sudden 8 hours of activity, right? And so they end up making concessions in terms of the specificity with which they manage things, right? You either get a lot of false positives or you start to make that a little bit more fuzzy and accepting. And that's kind of where your real actual attack surface is going to end up being. So here's a couple of them, right? After hours ratio. So somebody comes in and consistently commits from 8 to 5. All of a sudden you see them committing at 8 p.m., on a Saturday. It's probably bad. It's either you got the problems and that's tracked through, like a outage ticket or something, an on-call. What do you call it? Or email. Very likely, that's going to identify actually malicious behavior. They're trying to grab foothold into that process. And if they do miss, they already have read and write access to something. So, the after hours ratio is an interesting one. I never really considered that, but that's like, I'm the worst person to do this on. I contribute to 1 a.m., 2 p.m., noon, and lunch, all over the place. But most people don't. Most developers kind of consistent on this. So, and then deviations. So this is kind of where we start getting into that score, right? The actual colonies score. So, in one of these examples, I'm going to show that was XC, the contributor that had been inactive, right? John Tang ended up with like a 5.6 times deviation score on the activity because the account had been inactive for so long. And then it actually ended up committing during times that it had previously not committed. So it had not only become active with writability that had not been removed, but it began committing at a time when the previous owner of that account didn't typically commit. So this would have stopped or at least identified an anomaly in that behavior before XC really even got popped. So the way to know that would happen in the same way that would have detected that way earlier, but then did. Here's some of the tools, right? So, MMaC Alert is the Marauders online map of active contributors. So that's going to pull down timelines, right? Your commit history has to be combined with the other activities and permission changes and build statuses and things like that. And what we get out of that first tool just a straight timeline, right? There's a commit, there's a workflow run, there's a failure, there's an issue that's open, there's a permission removed, right? As they said, juniors can't commit anymore. And then we start building behavioral metrics on that. So this again is one of those places where I do think like, I have an LLM integration here that you call your local LLM. I've got some that are trained for this specifically. But it can better adapt dynamically to patterns over time. So it can say like, okay, over summer, like this was a student contributor, with an internship. So they contribute and then they taper off and they come back into a full-time employee with the same username, but it can adapt to that. Whereas other systems are typically in a static, you're saying that should have always been that way. Any year postpart was. And as we get to vuln identifier. So this takes each one of those contributor scores and maps it against the vulnerability ethics. Think of that time. Yeah. And then finally, we look at the compound chains, right? So most of these vulnerabilities, with the exception of secrets leaking through workflows, are not by themselves devastating, right? So you have somebody that contributes, that push a PR, somebody's, denies it, says, what is this crap? No big deal, right? It's when we start getting these compounds that we actually get real problems. So we push the PR, we force merge, or we have somebody that rubber stamps reviews, right? So that's another one behaves if things that you can also target, or we can identify as a potential weakness or processes. And then inherent support source. So, across 38 public IAC repos, 321 critical findings that would immediately lead to a compromise or flow. That's the repository and the infrastructure related to it. And over almost 1,400 high findings that combined would also, can lead to full process takeover. So here's kind of the 8 ways that I was evaluating how a contributor is interacting with the repository base. Enough so as their behaviors, right? Well, so you have an contributor. That's going to be somebody that's opening issues, somebody that's just, developer, your maintainer. So that's going to be your on-call or your support desk or, somebody that's kind of things driven. Security, days yours, tell them that. If this one in a SQL rotation, I think that infrastructure. So we have the plan gates. That's a big one. If you do straight apply name or you can bypass plans, right? Without having them reviewed, that's a huge red flag. CI/CD. So pipelines in and of themselves have behaviors because they have dependencies. When your pipeline wakes up in the morning and it doesn't have coffee, you use this and it fails to build. As it times out, just get help to it have capacity. I'm not bitter, but if owners are actually really interesting, and it's really interesting with like hashing, like Terraform repository itself shifting from Hashimoto to the Hash Corporation to IBM. Within those exchanges, there's actually windows of time that some repositories were vulnerable to essentially owners that were removed from the repository for a period of time, but were no longer active. And obviously, everyone knows supply chain is a huge question. So I don't include supply chain in this demonstration because if I did, pretty much everything's vulnerable, right now. It should be. And then access, as simple as that seems, right? You've got branch protection, don't force merge domain. There's almost always somebody, probably the owner or the maintainer, that has override permissions, right? So if you give something like a rubber stamper with, a compromised owner, then, with compromised owner, you just force push, right? But that's going to typically flag something. Instead, what you would do is actually send a PR to somebody who's just going, yep, I know who that is. The code's always good. Hit go, right? Yeah. So here's examples of some of the behaviors that you're going to see out of each one of these fine checks, right? These glances that look at. So contributors will do an activity days, right? Did they go on a 2-week holiday? Or we see commenced during they're in France or something, right? We see after hours ratios. They're not consistent with their behavior, right? A lot of people will go home, finish up, or whatever. But it's when you see something out 2 a.m. from somebody that didn't never invest at that time that you go black. People worry about. And then, the baseline, the historical norms is interesting because if it has things like, they catch up, your junior tries to catch up on Saturday, right? And so you'll see that kind of activity. The cool thing about this is it can take that into account and not false flag that as malicious behavior. And then the deviation, right? We can see things as spaces we created a point for, a confidence rate, some of these, would have been pretty much immediately flag it. So again, here we've got dormant account reactivated off hours, plus they know the rover stampers, right? So that's actually, Bowman with cycling down there. Triggers unreviewed rush through the gates. And what they'll tend to do is take away the protections. So they'll change your branch protection, they'll change workflow, and they might export secrets to a third party. And then they're going to push that, right? Because they removed the branch protection. Now they can force a merge over the top of that after that workflow and to actually remove the evidence that they had done that in the first place. So, we'll see that later in a attack on those. these tend to go together, right? Security tooling built into your infrastructure, deployment, timeline, where you build pipeline, your CI/CD. And what we see is obviously you start seeing, I call them broken windows, right? Depends. You have to start even past 30 days, right? And now we're down to if you're not patching daily or you supply chain issues, right? Secrets rotation. Guys, why are we still doing whole secret rotation? It's 20 plays. IAC chain is per month. So that's interesting because if you have a project that is going to go into another iteration of greenfield development, for example, or a migration project, you actually see that start picking up. And those are things that you're going to target because they don't have consistent processes established yet for that type of board. 98, that's obvious, right? So we start tying some of these together now, right? So if I had long-lived credentials in there, and then I have infrastructure drift, which is going to cause failure to build, right? Because it's building against something that doesn't actually match what its state is. We end up reading things like secrets exposure through third-party logging platforms, things like that. This one just kind of pisses me off, to be honest. But it's so if you find these behaviors in a repository, almost guarantee that you can access, escalate, and maintain access through the pipeline itself. And that's another thing that I kind of discovered in this research was that it's actually a lot easier to maintain access through a pipeline than it is to maintain access to the infrastructure itself. If your IR teams are infrastructure heavy typically, right? They're very focused on, the cloud's supposed to look like this, you have your config management. They very rarely are looking at the actual runtime of CI/CD systems to say is it pulling in something after we've done all our scanning at keeping its persistent access just through pipeline. Another one that I do there is you can actually marshal things now into ticketing systems, right? So your malware can live as a charity issue, which is pretty fun. And then access, right? So any kind of branch protection changes, branch protection rules are complicated like S3, policy rules. They suck. A lot of people get those wrong. So when we see changes to that, that's again another attack surface. So you got that there. Yeah, that's all good. Okay, so vulnerabilities. I include 12 here. I have got 30 that I actually have with a lot larger scope in terms of the integrations that we can look at. But these are kind of the breakdown. We're above a follow 0.4 on S. Our primary signal's high, right? And it starts looking for secondary signals. So can we corroborate that is taken in an additional malicious action? So you're right. Or persistence or secret leaking or something like that. That's almost always going to indicate an attack in progress or an attack that's already been accomplished. Parts 4 are merge integrity and privilege, right? So if you have people that are coming on and off of projects, try and use, least privilege just in time and things like that. And keep your windows tight for when somebody rolls off a project. I know that's hard to do, but these are the things that we're going to look at because what they're going to end up doing is overloading your reviewers who are already overloaded, right? And they're going to end up getting QR for rubber stamps and, put something 4 or 5 layers deep into a third party platform call that pulls in a dependency that it's, you get, pre-release or pre-commits. GitHub. And, it was one of the there's the pre-commit and then there's the pre-circ. So GitHub would actually pull code from the repo up and run it before it actually did the commit to push all the files. And that's how GitHub get decompromised the first second time. But these are all related to problems with your merging, right? So your branch protections, number of reviewers. whether or not they actually review code as we're playing now in open source land and not doing, that's not working out as it should. And I ended up having to take out the bots halfway through this. They got really wild. People started throwing club bot in there, things like that. You can keep those in there and they are an attack path, but I decided to scope that outside of this if they don't want to focus on all that stuff. So, right. Unreview merge. Contributor escalation. Branch to action might have some privilege escalation. That's straight full attack chain there, right? That beast to direct control compiles of the workflow. At that point, you have access to the thing that deploys the infrastructure, all the secrets to do that. Life rates, basically focus on workflow injections. So if they have the ability to do a merge without it being reviewed and denied, this is where we're going to get things like the last edited, right? So is our workflow consistent? Like if they actually solidify that workflow or they make changes to it. If they make changes, it's great how you target the workflow. Secrets exposure is, the OIDC guys do federation, right, on those platforms. Make it their responsibility. Keep your token high short. Deactivate or actually invalidate your tokens at the end of your workflow runs. It's supposed to stay alive, and they have been exported. You still have a window of time in which that can either be used to be generate another token and maintain persistent access, or it could be used out of band just right there to enter that workflow system. Infra drift. I don't have a good answer for this one. Honestly, Terraform's terrible, Bicep's terrible, CloudFormation's terrible. Nothing really does infra drift over time. That's a big complaint in the GitOps and DevOps communities right now. All those tools are great as installers or removers, but not as managing drift over time. So I think we're going to see some new tooling in that space specifically. But until then, basically, what you end up with in like a Terraform repository is a plan, right? It generates this giant PR comment. Everybody goes, accept, right? And then they end up turning that off entirely because, right, it's been deployed. Normally, it didn't expect it. So, core, you end up with overstamp, right? Nobody puts time in their surrender there. They don't dedicate time to do review. Right? So anything where we see time taken out for, processes that have to happen for there to be security in place, it's not accounted for, in your teams, is going to end up with rubber stamp. Nice to tell his supply chain attribute, kind of the stuff, right? Other things that affect your pipeline that aren't necessarily your influence directly. It might be supply chain, RE by LLM, right? Things like that. Access policy is really interesting because you can get things like AWS changing the way that they do, policy templates for S3 and projects that are in maintenance mode that now enforce, a set of access restrictions. So, that's why we're seeing a lot of those S3 bucket issues, right? See, they're too complicated, so they just make it public by accident. Or they end up having a good set of policies, but their policy engine changes over time. The repository doesn't immediately. Central rotation. I don't know. We'll get different things from NIST about this. Should we rotate? Should we not? I wish it. Keep your totals short, right? Over 60% of the repos that I've scanned have credentials in there that have been rotated for over 360 days. And a lot of them have credentials over 1,000 days. Cool. So I ran this against 30 even year that we got. Of the 50 that I just grabbed, I said, go find something that has infrastructure as code, GitOps technology, Helm, Kubernetes, kube control, Terraform, CDK, CloudFormation, Bicep ARM, those types of things. It took out, 12 of them that didn't do an actual active deploy in the workflow files. And the remaining 38, almost all of them had persistent risk back. Works out these pretty good projects. Or we see what's two are the workflows, Terra, checkoff, actually all have pipeline that what's little issues like. And here we content chain, right? So again, only, all those by themselves don't really read to access, but it's when you start doing things like, okay, your dormant access gets an unreviewed merge or a rubber stamp merge. That leads to a reduction in the workflow permissions, right? Requirements and your workflow rejection. And now we have persistence. So, this is where really we start to bifurcate into attack and defense, right? So at this point, you could say, yes, but where can I detect this as a defender, right? And it would be at that dormant account. By set a policy of 30, you don't contribute for 30 days, I'm going to remove your access to the repository. You could ask for it back later, right? That's not a big deal. It's, or not them, not you necessarily. But if you leave them an access, now what do you, the ability to maneuver further into that? We're actually identified in those 38 repositories. Right, so we got SPY, SXC, SolarWinds. We had the rubber stamp injections. We like LLF. It was just going to compromise GitHub. Renovate roulette, right? Supply chain. So updating too fast where there's a supply chain compromise already, right? You can get that PR to pull a better version or sell and buy, hey, that's a vulnerable version. Go pull this vulnerable version. We get, DPO4. 05 is access isolation. So this can be something like the original branch protection is reference to group, right? The group no longer exists. So the branch protection fails in both cases of the owner and group and fails open, for example. And we had a 10 minutes, June, letting go past here. So, we do common scoring, right? And basically we get, set of point cores indicating and primary, anything but that's pretty much secondary, gosh. 13, 14. So this is how you would, see like the sleeping setup. And let me run. Awesome. Yeah. So, nope, that's not showing on this page, is it? Sure, where I do that. So my filter basically goes through, you can pass it an airdrop key, right? Or you can pass it to an OLM locally. So I use OLM or CP for that. Orbit summary is, again, that timeline is created. And you pass this in, it generates these profiles of the contributors. So I can go GitLab. So GitLab was kind of finicky. They have way reduced RAID minutes on their API. So like timelines, that. I don't look here because I can't see it. No. Okay, so let's try again. That was all set. Right. So like for Document, this is just like straight timeline already, but we're actually taking it in chronological order. There's no IC changes, and no, governance events, which is interesting. And then we start getting into profiles where for every contributor on that repository, it's going to generate a profile for that individual. Right. So that one's not interesting. So there's a lot of them that aren't, right? But for each one of the lenses, you get this individual, right, as a lens. It's same thing. So public contributor. Is it hard? No. So that's interesting. Okay. I just tricked one I ran in there. Sorry. And we're about 5 minutes, aren't we?
Yeah. We're getting close.
Okay. Okay. Bad demos. Sorry. This is essentially what you get is this workflow injection, donut, trigger escalation, and you merge. And what it's going to do is generate a full-blown red team POC, for you to target that workflow you want. Beat and blitzing and use the same thing, right? And that reads both ways. You can be standing in the hallway, wait for him to come, or you could do the guy sneaking around. So, it's one of the few tools I've seen that actually does both. And that's it. Sorry to run out of time, guys. Sorry.
1-2 minutes.
Yeah.
Yep. All right. Let's give a round of applause.